Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on January 29, 2026, about 5 days ago. It introduces a hierarchical diffusion model that completely bypasses fixed tokenizers like byte pair encoding, instead using a fully differentiable pipeline to process raw characters directly. The paper is titled Zonkey, a hierarchical diffusion language model with differentiable tokenization and probabilistic attention. And as we'll see later, the results for generating coherent text without standard tokenization are really impressive. So, Figure 1 visualizes the probabilistic attention mechanism, specifically for the phrase Alice and Bob. The heat map plots query positions along the vertical axis against key positions on the horizontal. The deep red blocks show where attention is fully preserved, essentially whenever the query's existence probability is high relative to the key. In contrast, the blue regions represent soft masking, where the model downweights the influence of certain tokens to handle variable lengths without breaking the gradient flow. While Figure 1 visualized the attention map, Figure 2 breaks down the underlying math for the segment splitter, using the same Alice and Bob example. The blue charts on the left track existence probabilities. Notice how in the top left the probability is high for Alice, but drops sharply for the subsequent words as the first segment fades out. Conversely, the bottom left shows the second segment picking up the remainder with high confidence. Then, the green charts on the right display existence shares. These normalize the weights so that overlapping parts, like and Bob appearing in both segments, don't count double in the loss function. Well, moving from segmentation to the generation process, Figure 3 visualizes the mixed-step training objective used in the denoising diffusion mixed model. Here, point 1 at the top left represents the clean target compression vector, while point 2 on the far right is the heavily noised version. The blue line connecting them defines the ideal trajectory for removing that noise. The model attempts to recover the signal, producing the intermediate points labeled 3 and 4. Crucially, the loss function forces these predictions to project onto that blue segment, ensuring the denoising step moves strictly toward the clean data rather than drifting into unrelated parts of the latent space. Wrapping up, 2 takeaways stand out. First, Zonkey shows we can replace rigid tokenizers with a fully learnable pipeline. Second, the model naturally discovers linguistic hierarchies, like word boundaries, without supervision. This points toward models that adapt their abstractions directly to the data. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.